So welcome to the fourth video in the quadratic series. In our previous lessons we talked about real solutions and non-real solutions. And so now I'm going to talk about very specifically the non-real or imaginary solutions. Okay, so we're going to begin then with the definition of what an imaginary number is. And so imaginary is represented by the letter I, and it stands for the value, the square root of -1. So that's its definition. So if you square this value, that's what it says here, I squared is equal to the square root of -1 squared, then the squared and the square root cancel and you get -1. So these are the two very important things off this screen that you need to remember, is that I is equal to the square root of -1, but even more importantly, I squared is equal to -1. And this here is the not. You have to square the square root instead of the opposite, because these are the two values you need to get from this screen. You can actually simplify square roots that have a negative under the radical. But it says here, which it's hard to see because it doesn't say, but it says you must always do the I part first. So in other words, on the square root of -28, you would rewrite it this way. It would be the square root of -1 times the square root of 28. The square root of -1 is I. And then if you reduce or simplify the square root of 28, you would have, factor it, 4 times 7. 4 is 4 times 4. The square root of 4 is 2. So you would have a 2 on the outside and a square root of 7 on the inside. Same thing for b. It's going to have I in it because this is the same thing as the square root of -1, or I, times the square root of 32. Well, if you factor 32, that's going to be 8 and 4, 2 and 4. In other words, 2 times 4 is 32. And because there are 2 4 factors, I can take that out. 4 times 4, as you recall, is 16. The square root of 16 is 4. But this is not a perfect square, so it stays underneath the radical. So the square root of -32 would be 4i square root of 2. You notice that you have a number, then an I, then a square root. You don't write the numbers and the letters after the square root, and that's really just for clarity. It's hard to tell where the square root ends. I'm going to leave the last problem for you to try in your notebook. So you can actually multiply i's together, right? So you treat them, they're a little bit different. You treat them like they're variables, but they're not variables. I is not a variable. I is just I, but it still has the same kind of properties. So to simplify this, you would multiply the non-I parts together, -6, and then you would multiply the I parts together, I squared. You would remember that I squared is equal to -1, and you would have -6 times -1, which is 6. To simplify anything under the radical, remember that you do the I part first. So this would be I square root of 12 times I square root of 2. That would be I squared on the outside. And then on the inside, if I go ahead and instead of multiplying it together but just factor it, I would have 3 times 2 times 2 is 12, and then times 2 here, and I have that is a group of 2, perfect square, so it comes out. I squared is -1 times 2, and then I had a 3 and a 2 left inside. So finishing this off, this would be -2 times the square root of 6. We can actually solve quadratic equations now that we know what to do with imaginary numbers. So to solve for y in this particular problem, the first thing I'm going to do is subtract 20 both sides. And I have 5y squared is equal to -20. I'm going to then divide both sides by 5, and I have y squared is equal to negative 4. I'm going to take the square root of both sides, and because this is a quadratic, it's going to have two solutions, plus and minus, and then I'm going to take the square root of negative 4. Well, the square root of negative 4 is the square root of negative 1 times the square root of 4. So this is I, and this is 2, so this is going to be 2I, plus or minus 2I. Because this is y squared, there's always going to be two answers. Always be two answers, and so this will be plus and minus. So this leads us to the next concept, which talks about complex numbers. Complex numbers are any numbers. In fact, any single number can be written in the form of a complex number. And as you can see on the screen, a complex number is written in the form a plus bi. So you can see that there's a real part and an imaginary part. So a plus bi. Here's the real part. This is real. And then the part with the I is the imaginary. So you can think that a real number like 6 could be written as a complex number, 6 plus 0i. A real number means that the imaginary part is 0. Or you could have a purely imaginary number, like a number like 2i. And you could write that as 0 plus 2i. So it would have a non-real part and a real part. But a complex number is just all of them. So you can see here, the 5 is the real part, and the 2i is the imaginary. The 1 is the real, the negative 3i is the imaginary. And so a would be 5, and b would be 2i. I'm sorry, b would be 2, and then the I is there. All right, so you could use that because this is a real strange thing. It's like I acts like a variable, but it's not. So it's a variable plus some additional properties. But a complex number could be set up this way. It says find the examples of x and y that make the equation 2x plus yi equal negative 14 minus 3i true. Right, so you would see that 2x would go with the real part, and yi would go with the non-real part. So you would see here that 2x equals negative 14, so x is negative 7. So x equals negative 7. Negative 7 is a value that would make that true. So you put that in, negative 7, plus, and now I'm looking for something that's yi. Well, yi equals negative 3i, so y equals negative 3. And you can see that this would be for x and this would be y. So just like variables, you can add and subtract complex numbers. You just have to remember to add the reals together and add the imaginary together. They are not like terms. So for instance, here if I write it without the parentheses, I would have, sorry I wrote that funny, 4 minus 6i, and then I would distribute the negative, so negative 3, a negative times a negative is a positive, so plus 7i. So I'm going to add the real parts together, 4 minus 3 is 1, and then I'm going to add the non-real together, and that would be plus I. All right, so here, instead of writing on this bottom part, instead of writing them, adding them sideways, which of course I could also just write one underneath the other and add them together. 5 plus 10i. And that's it. It's pretty simple. So just like adding and subtracting, you can also multiply. And so this looks an awful lot like using the distributive property, or sometimes we call it foiling two numbers. All right, and so I wanted to show you a box method. You can also do, multiply first times first, then first times last, and then these two, and then this one. You can always do that. Another way to do it, however, is to put it inside a box, and you can see that I've got 2 minus, let's see if I can point, 2 minus I, and then 3 plus 4i, right? So to get the answer inside this box, I would do 2 times 3. To get the answer in here, I would do 3 times this. Same here for this, and then this one for this one. Kind of like an Excel cell, right? So 2 times 3, negative 3i, 8i, and then negative 4i squared. Okay, and then you'll notice that these two right here are like terms. So you would have 6 plus 5i minus 4i squared. Remember that I squared, though, is still negative 1. So you can rewrite this as 6 plus 5i minus 4 times negative 1. And of course that's positive 4, right? So I would have 10 plus 5i. And it's the same thing over here. You would have 6 plus 8i minus 3i. Do you still see them in the box? Minus 4i squared. It's the same thing. It's just this is another, like when we did the X method, it's just another way of organizing the data. Okay, here's a problem I would like for you to try. Try it, multiply these together. And then also over here, I would like for you to multiply this together. And then one more, if you're up to it, do 3 plus 2i minus 1 plus 7i and see what you get. All right, I'm going to see you in class.